Hi friends, in this video we are going to see about binary search tree. It comes under unit 2 advanced tree. So now we will see one by one and comparison and advantage of it. So first we will start with tree. So tree is nothing but an hierarchical structured. It will use it to store the data in hierarchical order. So this is what the tree. So for a normal tree, root node will be there, only one root node will be there, and we can have n number of child nodes of any order we can store. So here the data can be stored in any order. Mostly it will use it to store in the fashion of left to right. So for this particular tree I can have n number of child. So it is used to store the values in any specific order. So one parent node we can have n number of child nodes in the tree. Where in the case of binary tree, one root node, only two nodes will be given as a child node. That is, your child node should be less than or equal to 2. For example, for a particular node, they don't have any child or one child or two child. Maximum of two child will be allowed in the binary tree. More than that, children is not allowed to construct the binary tree. So for this, one root node, we can include maximum of 2 children into the particular root node or parent node. So for this I can choose fill the leftmost element. For here I can choose the right, then 6, 7. So in this fashion I can insert the binary tree. For example, I may or may not have child node for a particular tree. So for this parent I have one child, and for this parent I have 2 child, and for this particular node I don't have any child. So this is what the rule for a binary tree. Maximum of 2 nodes will be created, minimum 0. So this is what the structure this is what the rule to form a binary tree. Bi means 2, so we can have maximum of 2 nodes as a child for a particular parent node. So the first topmost node will be called as parent node. So for this is a parent node. After this we don't have any children, so it is leaf node, and these will be called as intermediate node. Next we will come into binary search tree. For example, here in this binary tree, if I want to search the element 6, okay, so I want to visit the first node. Well, I will check whether this is equal to 6. It is not. So again I will move to second node. It will check whether this node contains the element 6. It does not. Then I will move to next element. 3 is compared with the searching element. It is not searched. It is not the equivalent element to the search. And for fourth element, it will be searched whether it is 6 or not. And for next element it is checked whether it is 6 or not. Then it is moved to the next element, and we are checking whether this element is equal to 6. Yes, it is 6. So then it is return the answer found, and it will mention the position of it. So in this fashion we can have we have to visit all the nodes to search the element. Once it is received or once we found the element, then we no need to move to the next element. So here the searching time will be increased in the binary search tree. Next for binary tree. Next for binary search tree we have a condition that root node should be left node should be lesser than the root node or parent node. Right node should be greater than the parent node. For example, here I am constructing 15 as an element root node, and I am inserting 10 into it, so this will be the lesser element. For example, I am inserting 20 into it. So if I again insert the element, for example 8, so 8 is compared with 15, so 15 is less than 8 is less than 15. So again it will test with the 10th next element in the left side. So again it is 8, 8 is lesser than the 10, so 8 is inserted here. For example, I want to insert 11, means I will check here it is lesser, then I will check here it is greater, though I can insert 11. For example 25, I will check here and this, and it is 25. So these are the three things. So for tree, we can have n number of child. For binary tree, maximum of 2 child. For binary search tree, we can have maximum of 2 child, and it is should maintain the rules that lesser value will be the left side and greater value will be the right side. For example, if I search value 11, means here I will search 15, it is not equal, then again I will move to the, it is lesser than the value 15, so again I am searching whether it is greater or lesser, it is greater, so I move to this one. So searching time, only 3 nodes I have searched for this particular search node. But in the case of this one, I have searched 1 2 3 4 5 6 times I searched. The searching time for this is higher, and for binary search tree is lesser. Thank you.